Good evening, and good morning. I'd like to introduce you to our next lesson in my journey to becoming a software tester as a manual quality assurance engineer. Before I start, I'd like to let you know this is for review, educational, and informational purposes. This is not to take the credit for the intellectual property. For this text that I'm using, the publisher, full credit to the intellectual property goes to the publisher, which is irjet.net. That is the International Research Journal of Engineering Technology. Okay. My purpose here is just to use the information that's in the public domain to educate people about the topic, to review it in terms of giving credit to the author, going over the material, not word for word, but to give understanding of the material, and also remember the key information or points for this part of the study. It's also to show what I'm learning as well for it. Okay, so again, the full credit goes to International Research Journal of Engineering of Technology. That's IRJET and www.irjet.net. This came out a few years ago. This is Volume 3, Issue 4, April 2016. And here you have the EIISN and the PISN numbers here. You can look it up yourself. And also, the credit also goes to Prasad Mahajan, Research Scholar, Department of Computer Engineering, Baharedi Vadeth, Pune, Maharashtra, India. Also, full credit for the intellectual property also goes to them as well. Just citing the sources here. Now, what I'd like to do is talk about the different types of testing and software testing. Now, remember that in software organization testing is done in which in software organization testing is done which is to use to identify quality of the software application. Nowadays, organizations mainly focus on software testing fields so that they developed applications to satisfy the customer as well as organization needs. So this is really organizational purpose. Testing is done with the intent of identifying the correctness, completeness, and security of the developed software applications. Now this can be web-based in terms of web code. This is HTML, JavaScript, or CSS. Now, what we're trying to do, and I'm not going to read this word for word for various reasons because I'm not. You don't need me to narrate and read this word for word, but just to explain to you the content. Um, Now, there are three different types of testing which are conducted at different stages. Okay? Now, the objective is to put all levels of testing where the objective and its purpose in a single unified context. Okay, you put this all together, but within a context that applies to all three of them. Now, this is basically just a cursory surface study of what's there. Now, what we're going to be learning is the following things: software testing in terms of the V model, tools in terms of alpha testing, beta testing, okay? And then also SRS. Software testing is a set of activities. By definition, let's define software testing. Software testing is a set of activities conducted for finding errors in software. This is the fundamental purpose behind software testing. It is a process used to measure the quality of the software, as we talked about before. Okay, now, this is a different types. There are different types of testing which are done at different levels. Each testing is done with different purpose. We have a V model, which is used to represent testing activities. It provides links to the software development lifecycle. Uh, software development, lifecycle, LC, lifecycle. I was thinking it was different acronyms. Software development life cycle. V model consists of a left arm and a right arm, which is like a left part and a right part, and it's known as verification, as the right arm is known for validation. Left arm known as verification. Right arm is known as validation. So we need verification and validation. Each verification activity has its corresponding validation activity. It's kind of like hot and cold and hot. These two go together. Left foot and the right foot and left foot, they go together. Verification activity has its corresponding validation activity. Automation tools are available in some type of testing, and the rest of the testing is done manually. So we have automation and manual testing. Now, the thing about it is that level one is manually, where you manually go through and test each part of the program. That's level one. That's what's called manual QA, or manual quality assurance. Then we have an automation, which is automation quality assurance. That's like the second part. Both one is you manually do it, the other one is you write code to emulate what a QA engineer or what a person who's doing manually does. Now, and of course, after that, you have the dev team, you have the programmers, and you have the programmers and checkers of the program. So basically, that's development, and then you have the developer operations, which is the one who checks the code from the program. Now, in terms of software testing, it exists because due to some challenges in software development, some issues were created to find out some issues were created to find out these problems. I'm going to say these. I don't want to be redundant. Say issues with issues. These problems to detect the defects before customer software is testing. Customer software testing is used. So we need to check that before it gets to customer software testing. This is basically your beta testing. Your alpha testing is basically that's basically your QA. That's either manual or automated. Now, and so you have manual. You have basically you have a cycle. Basically, is you set up the projects. Development team makes it. What happened is then it goes to QA slash or automated, depending on what it is. Goes back to the dev team, and then the DevOps also checks it as well. Now, here is the purpose of some software testing tasks. Number one, to find out defects as early as possible. Number two is to detect the defects or to execute defect reporting. Now, as we talked about before, I talked about also we want to check corrections are done for defects, which is after the feedback. And then we want to verify new defects has come into corrections, which is remember we have validation and we have validation and verification. For the V model is the model in which you represent testing activity from the beginning of application until its deployment. So this is from beginning to end. This is the software cycle that's called the V model. Okay? Remember, it's used to represent the testing activity from the beginning of application till its deployment. Deployment is when it's released to the public. V model consists of two arms, which I said before, which one is represents different activities with an applicable level of testing. Now, here, let's go from left to right. Is verification and validation. Number one, we need to consider the requirements for specification. Okay, that's the acceptance test plans. You know what? I need to probably change that. This is. I know. Okay, never mind. This is the acceptance test plan. Okay? I have it the other way, but for some reason this is not cooperating very Anyway, so between the requirements and specification, so requirements, specification to acceptance, so that's verification and validation. Requirements specification is so of those two parts of the V model for verification and validations. On the verification end, we have the requirements specification goes to acceptance test, which is the validation. That's part of what's called the acceptance test plan. Excuse me. Now we have the system test plan, which is the functional specification of the system tests. First, we need to check if it's functional. Then, second of all, we need to check the system that it's going to be run in. That's part of the system test plan. Now, on the third level, we have something called the integration test plan. What that is the system design going to the integration test. Notice how we have arrows. Okay, first of all, we go in this order. This order corresponds with the left corresponds with the right, but it's going down in order from 1, 2, 3, and 4. Fourth one we have is something called test cases. Notice we need to do in this order and not in the opposite order or mixed up order. For test cases, we have the unit design and we have the unit tests. And then finally, we have the code. Now, from the code, we have, okay, from this point, the code goes to unit test, integration test, system test, and acceptance test. So let's go from beginning to end. So remember we have 5 major layers. First layer is acceptance test plan, acceptance, system, integration, test, and code. Now, remember, we have requirements, specification, we have functional specification, then we have system design. We go from left to right. As we do verification, make sure we have it. One is functional, one is functional, and one is system. So we start with requirements, specification. We need to know the requirements, then we need to know the functions. We need to know the system that we're programming in, or how it's being used, or in what environment. Then we need to know the design for the unit. Then we need to know the code that we're using. From the code, we need to test the code with the unit test. In the unit test, we do the integration test. We put that into the code. Sorry, the code gets tested as a unit, and it's integrated. And it's put back into a system test as a second, as pretty much like a double check. Then we have acceptance test. Yes, no. Is this working? Yes, no. Can we implement this? Yes, no. That's the acceptance test. Now, remember we have the 2 main parts. As we said before, testing is broadly divided into 2 bases of their activity. You have verification and validation. Verification is on the left. Right part, the right on the V, this is on the V model. The right part is validation. So we go verification to validation. So you can see the flow of how this V model works. Now, when we're talking about verification testings, we need to understand that the verification testing software application is not actually executed by documents or code, but is checked statically to find out defects. Now, software development is based upon customer requirements, so the software application needs to confirm the predefined requirement specification. So what's the main idea? Predefined requirement specification. Make sure it fits that verification. Now, as a software development goes through different phases, it's necessary to ensure the deliverable of each phase is per specification. Verification makes sure that the software application is getting developed in the correct way with respect to requirement. Verification focuses on defects as early as possible. It means, are we doing the right job? It's very simple, but verification process. Verification is also known as static testing, as we said earlier. Now, the verification process ends before validation process starts, meaning you have to do the verification before the validation. Now, with the verification process, let's be clear on the verification. We need to be clear and understand the details of the verification process. Now, during verification of all the outcomes of software development, including code are read and reviewed by one or more responsible team members to find defects. Verification activity are conducted by the deliverables of development phase on the left part of the V model. We start going to left to right. It's kind of like Western languages. You write from left to right. Same thing with code, left to right. Verification activity are conducted as deliverables for development phases for the left arm of the V model, which you already know. Following different documents of such verification is done to find out defects. Number one, we need to find out software requirements specifications, as we said. Remember that it contains user's requirements that are checked in verification activity. Number two, it provides acceptance test plan which used in the acceptance testing. Thus, you can see why you need to do that first. Then, so we have software requirements for specification for verification. Second one is high-level design, so that's the design. High-level design document includes software specification. It provides system test plan which are used during system testing. Third one is detailed design document. That is the detailed design testing out the unit test plan. Remember that the unit test plan is used for conducting unit testing. It's almost self-explanatory. And then finally we have the code. Now code is checked statistically to find out defects in the code itself. Some of this is straightforward. Now when we talk about methods of verification, we need to consider that walkthroughs and reviews are two methods of verification used to stop incrementing defects in the next phases that are used to reduce the amount of rework. Okay, so from a project management standpoint, reducing the amount of rework. We need to stop incrementing defects in the next phase, and we need for the purpose of reducing the amount of rework. Now, the third thing is our walkthrough. Now, walkthrough is an informal process in which the intent of it providing information and receiving improvements. Remember, it's informal process with the intent of providing information and receiving improvements. Now, during walkthrough meeting, author describes the document to all participants of the meeting, then knowledge and doubts are shared. Walkthrough is carried out in the following ways. Number one, author explains the product. Number two, participants come out with defects and suggestions. Author provides clarification, suggestions are noted, and corrective actions taken. Now, we also have reviews. Review is a formal process in which we use to conduct verification activity. It is used to find out defects in formalized manner. That is, the customer, management, peer, and audit team are involved in the review activity. So, remember that's the formal process used to conduct verification activity. Testers are involved in requirement reviews, and following stages are of the review process. Number one, it almost sounds like common sense. Number one, read the documents and check the code. We need to know what we need to have, for all of the requirements, etc. And obviously we need to check the code. Number two, we find out defects. Number three, we document. Number four, we close the defect by taking corrective action. And after we've done it, we'll confirm closure of the defect through review. Now let's talk about, we did verification, now we have the second part, which is called validation. Now validation is the approach to evaluate whether developed application should Should functionality do what it's supposed to do, and it should satisfy requirements to the customer. Remember that it's approach to use to evaluate whether the developed application should have the functionality to do what it's supposed to do. Validation is done by executing the code to develop functionality. Validation is called dynamic testing. So we have dynamic and we have passive. Dynamic testing as validation includes actual execution of functionality to find out the defects. It focuses, are we building the right products? Remember, verification is, do we have the right product? Number two, are we building the right products? Oh, sorry, are we doing the right job for the product? Are we doing the right job? Right? Basically, is that the right function to create the product? Sorry. And then, are we doing the right products? That's what it is. Okay. With that in mind, remember it's representing the right arm of the V model. That is for unit testing, integration testing, system testing, and acceptance testing. It goes in that order. We don't skip steps. We can go from unit to integration to system, then to acceptance. Now let's talk about those in its own respective order. First of all, what we're going to do is we're going to talk about unit testing. Now, when it comes to unit testing, unit testing includes the testing of smallest piece of software to verify its behavior. We need to see how does this software behave. Does it behave according to how it's intended to? It ensures that the code should satisfy the customers. This is a repetitive point. And of course, it's done by developers. Of course, unit testing is done manually or by using tools like JUnit or NUnit. It is done to reduce future cost due to early detection of errors. And it tests smaller components so that it can easily find out errors. And then finally, we can do enhancement. Enhancements can be performed based upon that. Now, remember, with unit testing, we're testing out the code itself. Versus with the manual QA, we're just testing out the functionality versus this is testing code. This is the line by line small code, as opposed to the overall functionality is the tester, the manual or the automated QA tester engineer. So we have unit testing. Second thing is integration testing. Integration testing is done to ensure that the individually tested components can work together to perform the intended task. Pretty basic, right? Integration testing is important because modules work individually, but they may not work together when they are integrated. Modules work individually, but they may not work together when they're integrated. It's kind of like two pieces, right? Maybe, for example, one thing doesn't go with another thing, but they work separately. It's used to uncover problems which occur in interfaces between modules. Uncover the problems which occur in interfaces between modules. Now, the interface is something that you interact with during the process of using the software, or it could be in the case of something web-based, which is front end. It's not web, and customer doesn't use back end, uses front end. And this is what he interacts with to execute the function of the software. Following approaches using integration testing. Number one, we have the bottom-up approach. That is the approach that the modules are combined and tested when belonging to the bottom of the application hierarchy, starting with the modules at the top. So basically, you take the most important things first and least important things last. When top module is not ready, but bottom modules are developed at that time, the approach is used. Basically, you take its priorities by availability and by I'm sorry, it's used by availability and priority, or by what's most important. Now the top down, that's bottom up approach. You start with least important. Yeah, modules are combined with testing which belong to the bottom of the application hierarchy, starting with the modules at the top module. Now when you have a top down approach, this is different. What this is that when all the bottom modules are not yet ready at the time the top ones are used. So the question is, what is ready? Is the top ready or is the bottom ready? Whatever is ready will be tested first, then in order in terms of availability and in terms of order of priority. Now, stubs are used in a top-down approach. Stubs are a special purpose program which is written to test the integration between modules. It's basically a testing software, if you will. Now we have the critical part first approach, which is in this approach, critical parts of the system are implemented and tested first. Makes sense, right? You take the most important things, the most critical things, and they need to be tested first. When focus on an entire application is not possible due to time constraint, functionality is which is important and is concentrated first. Functionality. That's basically the testing. That's your verification. Is based on the functionality. And then, as I talked about last when we talked about the Big Bang approach, I didn't talk about all of these, but the Big Bang approach is a common approach in which all modules are integrated at once. No stub and drivers are required in this approach, but it's difficult to debug the code to find out. This is the drawback, okay? It's more efficient because you can integrate all the modules at once, but then it's difficult to debug the code and find out the location of the defects. So that's a major drawback. You're going to have to weigh the pluses with the minuses according to the needs of the situation. Now, when we talk about system testing is conducted to check that the system meets its functionality and non-functional requirements. Get this right. System needs system meets its functionality and non-functionality requirements. I'm trying to highlight all this. There we go. System testing is done after integration. After integration. Remember, we have to do this in a certain order. That's what it is. It is conducted on a complete integrated system to evaluate. What's the purpose now? Evaluate the system specified features. Right? We need to see if it's functioning the way it's supposed to function. That's the evaluation. It's done by a tester, of course. When all modules in the integrated state are working as a single application, the time testing. At that time, system testing is done. So modules are in an integrated state, working as a single application. And at the time, system testing is done. So what we have performance testing, security testing. For testing, we have performance, security, should be configuration. There's a typo here. Configuration testing, installation testing are done during system testing. So you have performance, security, configuration. I think they have a typo there. And installation testing are done during system testing. Now, these are all components to make the program work. Now, last one is user acceptance. Now, user acceptance testing is the final step testing before the system is accepted for its intended use. It makes complete sense, right? How can you accept something if you haven't tested it, you haven't integrated it, Actually, if you really want to understand, you can actually go backwards. It's called a reverse strategy. See, how can you accept it if you haven't tested it in its system? How can you test it in a system if it hasn't been integrated? How can it be integrated if the unit has been tested? And how can the unit be tested without the code? How can you use code if you don't have a unit design? How can you have a unit design if you don't have a system design, which is going to interrupt or interact in the system? And then how can you have a system design if you don't have the functional specification, meaning what should it be doing? And how can you have a functional specification if there's no requirements to, in other words, for what it should do? So you notice it's going all the way from requirements all the way to acceptance. It needs to be in that specific order, left or right. Remember, for acceptance, basically from start to beginning is acceptance test plan. Okay? So technically, uh, so we have the acceptance test plan. We need we need to do requirements before you do that. To get the system test plan, we need to have the function specification. I'm just showing you how the root of the root, why you have to do things in this order. And then for the integrated test plan, you have to have the system design first before you integrate it. And for the test case, you have to have the unit design before you test the unit. And then obviously in between, you need code to make it work and to test it, etc. User acceptance validates both functional as well as non-functional specifications, as we talked about before. User acceptance or UA, this is UA meaning user acceptance, is done according to user requirements, we talked about before, why, to confirm the application is behaving as expected by the customer. It is usually done by customer or end user. And remember, and then we have two types of user acceptance testing. Remember, this is at the end, not the beginning. This is the very last step. It goes in this order. Alpha testing, beta testing. Alpha testing is internal testing by the team, testers, the developers, etc. Beta testing is something that's a limited release that can be tested by the end user. Now, for alpha testing, it's done after system testing. It is done at the developer site by customer, like I told you, and is performed in a controlled environment. This is internal testing. Beta testing, let's look at the contrast. Beta testing is done after alpha testing, like I told you, and beta testing developer is not present at the location. Oftentimes you'll have a limited release, like customers get a first peek at the software. They will reveal some testing. Okay, you may have some marketing groups, or let's say game testing, what they call game testing, that could be a beta testing. That's technically it's part of alpha, but it's also part of beta, beginning of beta too. Technically it could be both. Okay, now it's conducted at customer site by the end user. Exactly. So you can have beta testing um, that's where the customer is. Remember, if you want to think of this in a simple way to remember and understand it is alpha testing is done by internal users. Beta testing is done by external users. Alpha testing is the development and testing team. Beta testing is the customer. Right? That is the external. Now, when we talk about comparison of different levels of testing, remember we have unit testing, integration testing, system testing, and user acceptance testing. Now, for the unit testing, we have the developer. It's done by the developer. Testing an object is code. Code is tested. Focus of testing is user meeting its specification, and defect is code-related error. Integration testing, we have testers and developers. have interfaces between modules and testing. We have the interfaces, so testing an object is interfaces. Focus of testing is interfaces as well, because that's what we're using to communicate with the software. The defect is a control flow error, which we'll talk more about in the future. This is the control flow is basically what's the order in which things are done. System testing is testers and developers. Then we have complete software, and then for system testing, in terms of testing an object, that's complete software application is tested. Sorry, focus of testing is functional and non-functional requirements. We already talked about that as part of system testing. And then, of course, for defects, for unit testing, it's code-related error. Defects for integration testing, it's control flow error. Defects for system testing is functionality. If the functionality is not working correctly, okay. Now, what we want to do is we look at the categories. We can see what unit testing is, and who's doing it, who's testing it, who's focusing on it, and what are the defects. Now, use acceptor testing. Um, each category is who's doing it in user testing, integration testing system, and user acceptance or UA. And it's done by customers and users. That's your beta testing. Excuse me. Yeah, that's your beta testing. Yeah, is customer and end users. Testing an object is testing with respect to requirements. This is focus of testing is functionality from the user's end. Again, we have the user end. And then defect, we not as per user needs, meaning there shouldn't be any defects. Okay, there's error reporting and error reports. Now, non-functional testing, as a matter of definition, this type of testing carried out during system testing. The aim is to test the software under different conditions. Should be conditions, not condition. Now, here's a testing that you're going to carry out. Okay, we have usability testing. Usability testing is done to check the ease in which ease of an application. Remember that when we test something out, we want to see it from the user's point of view. And when we develop software, we want to do it to make it as intuitive and user friendly as possible. Yeah, so exactly how I didn't even read this. It says usability determines how how it is easy for a new user to carry out basic tasks of an application. How easy is it? That's the usability testing. We have load testing. Load testing is conducted to understand the behavior of the system under specific load, which is mentioned in the requirement document. Conducted to understand the behavior of a system under specific load, meaning what are you telling it to do? How does it behave? We have volume testing. So remember, we have usability, load, and we have volume. Volume testing refers to the testing of an application with huge amounts of data and checks its limitation. This is basically an extension of load. But load is just what it is. Volume is how much it is. Then we have something called stress testing. Stress testing is used to determine it's used to determine the ability of an application to maintain a certain level of performance under unfavorable conditions. Maybe you have too much on it. The reason why you do that is to see what will happen when you do X, Y, and Z. What happens when you do this? What happens when you do that? Or what can trigger let's say, a buffer overload, buffer overflow, or what can trigger like a crash of the system. That's something that the stress testing can tell you. Now we have the performance testing. Performance testing tests how well an application behaves in respect to the performance requirements. So these are different types of testing. Okay, how well an application behaves in respect to performance requirements. Is this application meeting the requirements that it's supposed to perform as? Okay, that's the question. Then we have configuration testing. Configuration testing is done to check how the application behaves in a range of hardware and software configurations, which design. This is where we can check compatibility, basically. Configuration is, well, the next one's compatibility, but it's the range, basically what range of hardware is, what range will this hardware and software be designed for? What else? Sorry, excuse me. Application behaves on a range of hardware and software configurations. So it's designed for this range of hardware and software. How's it? How does it behave? According to how it's what its range is designed for. Then we have compatibility, which comes next. So it goes from in this particular order. Once you've configured out the configuration test, we're going to go with compatibility testing. It is done to test the application for the configuration for which it's designed. So we test the application for the configuration, check its compatibility. For which is not for which is not designed and check its compatibility. How does it behave in environments where it's not designed for it? Can it work or does it work? It includes testing of application on different platforms. So when they say platforms, they're referring to operating systems. And then we have security testing. Now, this is where DevOps comes in, is developer operations. Is they will check for certain security holes in software. One example is buffer overflow. Security testing is done to determine that an application protects data and maintains functionality access as intended. So each one of these testing has different phases with different types of testers that are involved, depending on what's required for testing in terms of competency and in terms of other reporting requirements. Now, in conclusion, we want to say that in software testing, there's different types of testing which are done for different types of purpose, as I just said. So that a quality product is developed. The main objective behind this is develop error-free software, adequate verification, and lead to less issues being present during validation phases, as most issues are already discovered and corrected during the verification process. Sorry, verification and adequate validation process or testing. Actually, is we process, not testing. It will ensure that software applications developed as per software artifacts finalized in verification. So basically, is it function according to the requirements? And can it be verified that it's function according to the requirements? Therefore, it's important to know all the testing activities and validation of the verification process. Okay? Now remember that it goes hand in hand as they reduce future rework and costs. Remember, these two work together. The left of the V model and the right of the V model. Remember, the left is verification, meaning does it actually do what it's supposed to do? And then verification is does it function according to its features? Okay? According to what is the functionality there? Number two is the is the does it function code wise? Is there anything wrong with the code itself? Is everything in the code correct? So one is functionality and one is technicality. So one is does it work the way it's supposed to work, and the other one is it functioning the way it's supposed to work. I believe. One is a working, one is a functional. Sorry, one is a feature based, and the other one is a functional in terms of its code. Now, again, I would like to let you know that this was um, brought to you by. This was developed. This paper was developed by International Research Journal on Engineering and Technology. That's RIJET, as in the website is www.irjet.net. We talked about different types of testing and software testing. Remember that the authors of this are Prasad Mahajan, who's a research scholar, Department of Computer Engineering, Harthi uh, Vayadith Pune, and which is from Maharashtra, India. So we have those two people. And then the sources that the author cited, which I'm going to cite as well, which are the references. Jovanovic Irina Software Testing Methods and Techniques. Number two is Professor G. Satyat Revel, TM Bangalore, V2U Learning R. Roger, Roger S. Pressman, 7EB Software Engineering, a Practitioner's Approach. Number four, E.T. Huda is the Research Scholar, Department of Computer Science and Applications, University at Rotech, 124-01, Ionic India Software Test Process, and Testing Types and Techniques. The fourth one is Shikamvar Hasmikrel Tereddi, is a Senior Systems Administrator. Avnagar from Gujarat, India, at Software Testing Techniques. Sorry if I mispronounced the name, as they're not easy to pronounce because I don't speak Hindi or whatever language, but or at least the language of India. I did my best to pronounce it. As for the first one, that I believe is the Eastern European name, I do apologize if I mispronounce it, but these are the references that are cited. Okay, now, with that said, I would like to thank you for watching this video. I would like to reiterate that I'm doing this to show my journey into being a manual QA engineer, which is a manual quality assurance software tester, and my process in learning the material, communicating it to other people where it's in the public domain, and providing information and the education for the people who are also interested in it, and to show how someone like myself can learn it and other people can learn it themselves as well. So please click like on the video, that way it'll be pushing the algorithm, more people will be able to see it and benefit from it, especially if they want to be a software tester. And if you haven't already, please click the subscription. Excuse me. If you haven't already, please click the subscribe button. That way you'll have access to all my videos on this channel, as I do have a variety of content on this channel. Also, if you haven't already, please click the bell button. That way you'll be notified of all my future videos. I would again like to thank you for watching this video. I'd like to wish you a great day wherever you are. Take care, and I'll talk to you tomorrow.